Hello and welcome to this course on Pandas for Python. Pandas is a module, a package for Python that allows you to do data processing. So in this two-part course, we're going to look at how that works. Now I'm assuming at this point that you can already do a little bit of Python. We're going to need some of that competence as we look at this package. The first part of this course is mostly concerned with just blitzing through a lot of different things that Pandas can do. I think you'll be impressed. But so it's going to be a lot of, I'll show you something and then I'll give you an opportunity to go and try it out, and then we'll come back and we'll discuss. I'm going to be on Microsoft Teams in the chat the whole time, so even though these videos will enable you to go at your own pace, you'll still be able to come and chat with me and chat with everyone else as we go. And then the second part of the course, we'll wrap up a few bits and pieces, but primarily we're going to be looking at this one project. And in this one project, I'm going to give you a large Excel file full of student exam results from a physics department, where I'm going to ask you some questions like, which were the, can you work out the mean exam results of the students? Can you give them grades? Which students came top? The students are in tutor groups. Which tutor group did best overall? We're going to look at data with some holes in it. So hopefully it'll be a good representation of the sorts of problems that you're likely to want to try and solve using Pandas. So that's what we're aiming to do. We're hoping to be able to create some programs. We're going to be using Jupyter notebooks, and we're going to look at some error messages as well, so that you have some familiarity with that as you learn the Pandas syntax. So I hope you enjoy.
So you should have already found the GitHub repository where we're going to have all of the files that we're playing with, and it contains the script for today's and the second part's course. It's at github.com/petnut/course-pandas. And so if you scroll down, as you've already done, you'll see there's a bunch of files. We'll come to these in a second. And then we have a lot of notes about the stuff that we're doing today. So we've got the course aims, which I've already discussed, and then the prereqs. I'm expecting that you have some familiarity already with basic Python. Maybe you've taken the Graduate School's Python course, or maybe you just have a bit of experience already. That's all good. I'm assuming that you're probably by this point using your own laptop. So you need to make sure that you have Python installed and that you have certain modules installed as well. So you need to install the Pandas module, XLRD, that's short for Excel Read, that's going to enable us to read Excel files, the stats models package, and of course matplotlib. If you've done stuff with or scientific stuff in Python before, you've almost certainly got this one installed already. So I'm going to be using Jupyter notebooks to do some of the stuff, so you can follow along as well. I'll show you how I do that. But of course, your experience with Python may be slightly different. So one experience you might be having, or you might have had with Python, is that you have Python, you open up in a terminal window. This is what it looks like on a Mac. And you type in Python, and now you have something where you can talk to the screen. So you can give it a nice Python command like "Hello world," and it will do exactly what you ask. So a call and response interface. We can exit. Or you might be familiar with Python as having written a script somewhere else, and maybe in an editor like Atom or in Visual Studio or something like that. And then you come to run it at the command line by typing Python and then the name of the file. You press enter and you hope that it works. Oh, okay. Well, it looks good to me. You're going to have to, install the packages that I have listed. So if you don't have Pandas, XLRD, Stats Models, Matplotlib, then I'm going to have to ask you to do that. So you need to do pip install Pandas. This is from the command line. Pip install XLRD, pip install Stats Models. These instructions might be slightly different depending on what system you have. Now in a moment I'll give you an opportunity to check that these things are installed. And I'll give some assistance as how you might be able to do that. I'm first going to show you how we're going to get from this to the Jupyter Notebook. So we're going to load up a Jupyter Notebook after we've downloaded the files that we need. So if you go up to the top, you will be able to see the list of files here. If you go to clone or download, then you'll be able to download the entire repository. You can download it as a zip file. So I want you to go up to the green button, download everything as a zip file. You can ignore this because it's downloading. Then I want you to save the file. Now, depending on which browser you're using, that might appear down here at the bottom left-hand corner. In Firefox, it shows up here. So I want you to save the file. And I want you to then, it's a zip file, right? So I need you to then go and extract it. So I want you to open it up and I want you to extract it. And then once you've extracted it, so let me show you what that, okay, so here it is. Here's everything. I want you to go ahead and I want you to copy the examples folder. So I don't want you to go into it. I want you to copy the entire examples folder, copy it, and I want you to paste it somewhere that you can navigate to easily on the command line. Right, so for example, pasting it on the desktop is an excellent choice. So I'm going to go and copy and paste this, and I'm going to paste it on my desktop, but you can paste it wherever you like. It's up to you. So I'm going to do that now, and once you have pasted it onto your desktop or somewhere you like, then go ahead and open it. So here is the folder. You can see that I've placed it in my desktop down here. It's the examples folder, and it's got 4 different files in it. So in a moment we're going to go into these and have a look at them. I promise that this is the hardest part of the entire course. Once we're here, then you can go back to the command line, and we can navigate to the desktop, and we can navigate to the examples folder, and if we can do an ls to check that everything's in there. This is a good place to be, and just at this point we're almost ready to launch Jupyter Notebooks, but first we're just going to check that we have everything installed. So an easy way to check that we have the modules that we need installed is to just try and install them. So again, the experience is going to be different depending on what type of computer you have on a Mac. You will want to try pip install pandas, as I've written down here, and then if you've already got it, it will tell you requirement already satisfied. If not, it will go ahead and install it for you. So go ahead and do these things down here. On Windows, the interface might be different, but I'm not sure what it is. I'm going to try and give you some support in the comments if it's not clear to you. I'm going to give you a moment to do that now, and once you're ready, everything's good to go, then we will continue. So I'm going to place a pause in the video, pause it, and then come back to the video once you've managed to get that going. Alright, so we're ready to go ahead and run Jupyter Notebooks. Let's go ahead and do just that. So we're going to type in here, we're going to type Jupyter Notebook. So in the terminal window, we're going to type Jupyter Notebook. It's going to be in the folder that we already created, the examples folder. So we can have Jupyter Notebook. We're going to type that and press enter, and what you're going to see is this browser window will show up. So in your browser, you'll get a Jupyter Notebook popping up that looks like this. It'll have the names of the files in them here. Once you've got that, then we can go ahead and go up to New and select a new Python notebook. So this could be Python 2 or it could be Python 3. It's probably more likely to be Python 3 on your computers. It doesn't matter, either will be fine for this course. So go ahead and click New Python 2 notebook, and if you see something like this, then we're ready to go. I'm going to talk a little bit before we get started about what Pandas is and why Pandas is a good tool, and then we're going to come back and actually do some live programming. So let's talk about pandas. Pandas is a Python module. And this is really good because Python is a fantastic language. It's super extendable. It's got loads and loads of packages and modules that you can just import and get using. Um, Pandas is particularly well suited for large data sets. It basically allows you to import large tables of data and manipulate them in a similar way to you might have done using NumPy. So the context, the interface is nice. The language is well written, and I think you'll find it's quite powerful. If you've ever tried to do any sort of data manipulation in MATLAB, you'll know that MATLAB can be a little bit awkward with things like, or even just like data where bits are missing, or there's random bits of text in it, or dates. MATLAB struggles with that, but Pandas really doesn't. Pandas is sort of newer and has a good number of powerful tools with doing these sorts of things. So I think you will enjoy using Pandas and you'll find it quite powerful. On the other hand, obviously you need to know Python. There's no graphical interface. If you're used to doing data analysis with some buttons to click or something, then Python isn't going to work or Pandas and Python isn't going to work like that. But I think you'll get over it. I think it'll be fine. And of course, you need to make sure that the packages are installed. In my experience, that's actually easier running on your own computer than it is on the college computers. So maybe that would be too much of a problem for you. So yes, getting started is a little bit awkward, but we've managed to do that now. And now we have access to these quite powerful data manipulation features. I would say if you have huge code, so we're talking tens of gigabytes, then Pandas probably isn't the right solution. There are sort of lower level solutions like awk, AWK. It's a Unix level, very basic sort of text processing command that allows you to do very simple data stuff with it, but is extremely quick. So if you have extremely large files, it's a good way to chop down your data. But I would say for medium to large data sets, up to a few gig, Pandas is a pretty good choice. All right, so let's move on to section 2. Let's get started. Enough of me talking. I think we should actually be doing something. So I said we're going to be using Python. Well, I'm going to suggest that we use Python 3 syntax. If you're using Python 2 like I've been doing here, that's okay. We just need to copy and paste this line here at the top from future import print function. I'm going to head over to the notebook, which is where I was over here, and I'm just going to type it in. So you'll be able to, if you're using, as I say, if you're using Python 3, Python 2, that's fine. You can just copy and paste this from the GitHub. So from the future, we're going to import print function. But let's make that a bit bigger for you. There we go. And you can use Shift Enter to run a cell. Oh, I missed a space. There we go. Shift Enter to run a cell. You know that it's worked because the number appears here. If it's thinking about it, it's a star. If it's working, you get a number. All right. Let's do a simple test. Print hello world. Well, we asked it to do that before. Let's do it again now. Shift Enter. Hello world. Nice. Okay, so now here's the moment of truth. We need to go ahead and we need to import Pandas, and we're going to import it as PD. So we're going to use this PD shortcut. Shift Enter. You see it's thinking about it, and now we're good, right? And I also want to, a little bit later, I want to import matplotlib's plotting functionality, and I want to do some slightly more advanced stuff. So I'm going to use the standard import command for matplotlib, which is import matplotlib.pyplot as plt. All right, so those are the standard starting, and these are indeed all on the GitHub, so you can copy and paste these. Let's go ahead and read in our first data file. So let's let data equal pd dot, it's a CSV file, and the first file is called a1 underscore mosquito data.csv. Now I'm going to show you at this point what this file looks like. So we know what we're doing before we go ahead and actually import it. So I know that you have, so recall in the downloaded folder, here it is, a1 mosquitodata.csv. This is a comma separated value file. If I go ahead and open it up in Atom, which is a text editor, then you will be able to see what it actually looks like as a bunch of text. Here it is. So you can see we have some column headings: year, temperature, rainfall, mosquitoes, and we have a bunch of years, bunch of temperatures, bunch of rainfalls, bunch of mosquitoes. All right. Or like all good CSV files, you can also open them up in Excel, and Excel does the formatting for us. So it makes it into a nice table, which is a nice feature. So Excel's just loading, and I'll show you what that looks like. Here it is. Here is it. So again, you can see we have some years, and then we have a bunch of temperatures, a bunch of rainfall, bunch of mosquitoes. So what this data is a measure in certain years of the average temperature. This is in Fahrenheit. We have the total amount of rainfall over a period and the total number of mosquitoes counted. Right, so a good question is going to be something like, does the number of mosquitoes counted depend on the amount of rainfall that there was, or does it depend on the temperature? Do you get more mosquitoes in hot years, or do you get more mosquitoes in wet years? That sort of thing. So that's our short data set. There's a larger data set which we'll play with in a bit, but that's our small data set there, which we'll start to play with. So we're going to read in this as a CSV file. Here is the command. Shift-Enter to execute. All right, has it done anything? Well, let's see. If you're in a Jupyter notebook, you can go ahead and just type in data, like this. So at this point, I'm about to show you some simple functions, but I'm going to pause and let you read in the data file and just type in data to print it out like this. Okay, so we were able to print out the data table. You can see that Pandas has in fact nicely formatted it for us. I mean, I suppose it's quite nice. Alternatively, if you prefer your data printed out old school, you can ask for print data, and also Shift-Enter to run, and you can print the same data out as a bit of a table. There's some things to notice here, and the same is true for both of these things. So I'm going to scroll up to here. Do you see that Pandas has included an index down the left-hand side, which isn't there in the original data? So this is important. This allows us to refer to these rows by their index. And do you see that the indexing starts at 0? Because Python, like all sensible programming languages, starts counting at 0. Right, so the first row is 0, the second row is 1, and so on. So there are 10 rows, and so the last one is number 9. Okay, let's have a go at some very standard Pandas commands. Suppose we want to take a look at the top of our data. Try data.head, and you have to put these open brackets, close brackets afterwards. Data.head shows you the top 5 things. Any guesses what the command might be to show the last 5 things? Well, I feel like one of you definitely, telepathically and through time, I felt like one of you definitely thought data.tail, and you're correct. Good. That shows you the bottom 5 rows of data. Say you want a random sample. Data.sample randomly picks an item for you. If you run it again, you get a different sample, I suppose. Well, I suppose you're likely to get a different sample. And then here's a really powerful command: data.describe. Have a look at what that does. Data.describe gives you quite a lot of information about each of the rows. It tells you the number of items of data, so obviously there's 10 in each row. gives you the mean, so it's the mean temperature, 80 degrees Fahrenheit, mean rainfall, mean number of mosquitoes, the mean year, 2005 and a half. Okay, perhaps not that useful, but there it is anyway. They've got the standard deviation, the minimum, and then you've got the actually these are all quartiles here, aren't they? So you can see at a glance all this information. Let's go and try and pick out some more. Let's just try and pick out some columns. So we just want the years. We can do that with data and then square brackets and then year in quotes. Okay, so it's square brackets for selection, just like in NumPy. And I said you can use double quotes as well. That's also fine. I'll just show you that either works. And if you want to take multiple columns, then you can. And the way that you do that is you, instead of giving the name of the column, you have to provide it with a list of the names of the columns that you want. So we have square brackets here on the outside for selecting, for data selection. And now you need to replace this 1 year with a list of years. And of course, lists in Python also use square brackets. So we have another set of square brackets where we're going to have year, and let's also pick out the mosquitoes column. In this course, you will realize that there are two different ways of spelling mosquitoes, both with an E here and a not. We're going to spell it like this. So we have to have two sets of square brackets if we want to pick out multiple columns, right? The outer set of brackets for selection, the inner set of brackets for the list. So let's run that. And there we have the year, the mosquitoes, and again the index is down the side. Now suppose we want to pick some rows instead of just the columns. We can do that, and we just have to refer to the data by a range of rows. So say I want the first two rows. Okay, so that's a range from 0 to 2. Remember that ranges in Python include the first but don't include the last. So I think this is a good convention because it means that if you do the last minus the first, it tells you the length of the array, right? If you don't have that convention, like in MATLAB, then it's a fences and fence posts problem. So 0 to 2 is a range that is 0 and 1, and that's it. So that should give us the first two rows. Let's see whether it does. And indeed it does. All right. So I'm going to go ahead and give you some challenges now, something to have a quick play at, give you some time to play with these. And here are the things that I want you to try. I want you to print the last 3 rows. So think about how you might go and do that. And then I want you to try and print the first 2 rows, but only the year and rainfall columns. And then I want you to try to print just a single row. So have a go at these. Just something for the last 3 rows. So you can maybe think of a way of doing that using this sort of syntax. Just as a hint, you see data.tail here is a function, but there's no argument. I wonder what happens if you put a number inside these brackets. Something to have a play with, I think. So have a go at these. See how you get on, particularly with this last thing that might not be so obvious, and then come back to the video. All right, let's go ahead and try and print the last 3 rows. So something that you could have done is you could have asked for rows 7 to 10 explicitly. You could have asked for rows 7 to just the end, right? And you will remember with sort of this NumPy type syntax that if you don't specify something, it counts it as being to the end. So that would also work. Here it is. You might also have remembered that if you want to count from the end of a data set, or indeed of an array in NumPy, you can use negative numbers. minus 3 to the end, starts counting 3 away from the end, and then goes to the end. So that would also work, minus 3 to the end. Or I suggested that what happens if you put a number inside the tail function? Let's have a look. Aha, it does the same thing. By default, head and tail give you the top and bottom 5. If you ask for a number inside the brackets, then it gives you that amount. My second challenge was to print the first 2 rows, but only the year and rainfall columns. So hopefully you had a go at stitching some things together. So printed the first 2 rows. So we've done that already, right? That was 0 to 2. But only the year and rainfall column. Or you can go ahead and use the square brackets just right next to each other. So again, another set of square brackets for selection, and then another set of square brackets for the list. So it doesn't matter how many things are in this list, but if we have a list, then we have to have this set of square brackets for it. So we have this here selects the rows, this here selects the columns. Right, let's see whether that works. It does. Nice. Okay, what if it was the other way round? Maybe you tried that? If you haven't tried it, try doing this the other way round. Try it now, and then come right back to the video. Pause for a sec. Okay, if you try it the other way round, I'm just going to copy and paste it down here so we can compare. I'm going to copy the 0, 2 and paste it at the end. It also works. So the order actually isn't important, and that's, I think, something quite nice. The final thing that I spoke about was I asked you to try and print a single row. So maybe one of the things that you tried to do was to do data, say we want row number 3. And, right, okay, good, shift and enter. And how many of you saw something like this? Yes, because I did too the first time. If you're looking to pick out a single row, you can't do it like this. It doesn't understand, or it doesn't know how to interpret just a single number. So instead, you have a couple of options. So the standard option, if you want to pick out just a single row, is to use data.iloc. Data.iloc and then the square brackets will give you the row that you want. You see it's printed out in a slightly strange form, but the data's all there. Right? That's the year, the temperature, the rainfall, and the mosquitoes. And you can even use this iloc format with ranges. So if you want maybe 1 to 3, then you can use, so this will pick out rows 1 and 2. That is still counting from 0. So this also works. So you can use ranges with iloc as well. All right. You can combine these sorts of things to get single rows and single pieces of information. In fact, you might like to know that if you want a single row and you've already got some other condition, for example, the column, then actually it's fine to just ask for the number that you want in square brackets. It's only if it's just by itself that you have to use .iloc. Yeah, I know it's weird. It's just it's just how it is. We can ask for more. We can be more interesting about our selections. We can ask for example, the temperature, where the temperature is greater than, say, 75. So 75 degrees Fahrenheit is a pretty warm day. It's 20-something. I think it's low 20s Celsius. So that's quite nice. So maybe we're looking for all of the days that were decent. This is going to give us the temperatures where the temperature is greater than 75. All right, so that looks like it's worked. Notice that the indexing stays the same. Right, so it's 0, 1, 2, 3, 4, 6, 7, so it's the original indexing. In fact, why don't we have a look at what this is? What is data temperature greater than 75? let's copy and paste that, put it down here. It's just a bunch of true and falses. Right, so just a bunch of trues and a bunch of falses in the correct order. And so you're just passing a bunch of true or falses to data temperature, and that dictates whether it gets selected or not. You can see 0, 1, 2, 3 all get selected because they're true. 6 and 7 also true, they also get selected here. Okay. We don't have to ask for just the temperature where the temperature is greater than 75. We could also ask for, let's say, the temperature where the year is greater than, I don't know, 2005, say. Note that we have to use data every time, right? It's data temperature where data year is greater than 2005. Let's run that. All right, and this is what we expect again, because the later years are the higher indices, right? 5, 6, 7, 8, 9. So that also works. All right, I'm about to show you, or rather, I'm about to give you some more tasks to have a go at. So I'm just going to show you a few more things first. There are some nice built-in functions. We've already seen some of them. Data.mean, again with the round brackets because it's a function. Gives you the mean of the information, the year, temperature, rainfall, mosquitoes. We saw that with data.describe, but now we're also seeing it with data.mean. Now we're going to see that we can actually take data.mean and we can .mean that. We can just append all these dot somethings as much as we like, which is a really powerful technique. So we've got data.mean, and what that gives us, 622.85. And I know what you're thinking, what does this mean? And the answer is nothing, of course, because it's just average this, which is really complete nonsense. But it's good to know that you can do it. Notice that data.mean takes the mean of each of the columns, right? So it's the mean going downwards through the table, if that makes sense. So it goes, down the column like this. If you want to take the mean going sideways, then you have to use data.mean and then a 1 in brackets, right? So the 1 indicates the axis that you want to take the mean over. The default is 0, and that corresponds to going downwards, but 1 is going across. And in that example that I mentioned in the introduction of the stats data that I'm going to give you for tomorrow's session, where we have the results of students taking a course or taking a bunch of exams, one thing that you're going to want to do is to be able to average their results or take the mean of their results, which will be sideways. So this will be useful for them, even if right now it's going to look somewhat pointless. Exactly, what's the point of doing this? I've averaged here what the year, the temperature, the rainfall, and the mosquitoes. It's a complete nonsense number. But tomorrow or in the next session, that will be actively useful for you. Also, you've seen maybe data.max. That gives you the maximum data for each of the columns: year, temperature, rainfall, mosquitoes. And if you want to know the index associated with each of these things, so you want to know where is the year the maximum, where is the temperature the maximum, where is the rainfall the maximum, and so on, you can use data.idx max. Right, so that's the index, IDX, max, and that gives you the index corresponding to the maximum year, the maximum temperature, the maximum rainfalls, the maximum mosquitoes. Okay, and same for min and IDX min. You can also use things like .max or .min when you've selected particular columns. If you want the minimum temperature, you could also ask for it by taking data.temperature and then asking .min. You could do that as well. 74. All right. So I'm going to give you an opportunity now to have a go at these things that I've been speaking about if you haven't done already. And I'm going to give you a challenge. Here's the challenge. I want you to print the mean number of mosquitoes in the years where the rainfall was more than 200 millimeters. Right, so I want you to pick out the years where the rainfall was more than 200 millimeters, and then I want the mean number of mosquitoes from those years. Then I want you to do the same for when the rainfall was less than 200 millimeters, so more and then less. And then I just want you to print the standard deviation of the temperatures. So you might be able to guess what the function is there. I think we've hinted at it already. So it's not data.max or data.mean, it's data.something else that gives the standard deviation. Or you might have to Google it, and that's okay because the online help for Pandas is also really very good. So have a go at that, and then come back and I'll show you how I did it. Alright, let's first print the mean number of mosquitoes in the years where the rainfall was more than 200. So we want to pick out the number of mosquitoes in the years where the rainfall was more than 200. Alright, so in a moment we'll find the mean, but for now let's just pick that out. Okay, so in the years where the rainfall was more than 200, these are the mosquitoes. And then we want the mean, so we just add dot mean, again with the round brackets at the end, because it's a function. Did you get 211.83? That's 5, 6, right? Now do the same for when the rainfall was less than 200. Well, that's fine. That's we can just flip the sign on that, and I think we should get 160.5. Do you get that too? And then the final question was to print the standard deviation. Here it is. I print the standard deviation of the temperatures. And if you just did data temperature rather dot std for standard deviation, you would get 5.45. So that I think is how it's done. So I'm about to move on now to the next section, loops and ifs. So loops and ifs work in the usual Python way. So the usual syntax that you're using for loops and for ifs mostly going to work. There's one particular way of looping looping through data rows in Pandas that I wanted to show you, which is this up here using data.iterrows. So here's the plan. We're going to write a little for loop here that loops through all the data, and it's going to loop row by row, and the plan is it's going to print out the temperature in Celsius every time. So currently all the temperatures are in Fahrenheit. Now, in a little bit later, we'll see about adding a whole extra column that does the conversion for us. But just for now, we're going to just loop through row by row, and we're going to get it to print out some data. This isn't necessarily the best way if you wanted to do this sort of conversion, but maybe you wanted to do something more complicated, like you wanted to loop through a list of students, decide whether they passed or whether they failed. And if they failed, maybe you want to send them an email telling them that, or something like that. So like a good reason to be going through row by row. Data.iterrows is the way to do that. So I'm going to put that into our Jupyter notebook. You can go ahead and copy and paste this. I'm going to type it out so that we can talk about it as we go. So it uses this notation for index comma row in data.iterrows, and then colon, of course, for loops in Python. So then this what this does is it's similar to enumerate if you've used that in Python lists. So this is going to loop through all of the rows in data, and it's going to let the row be row. It's going to let row be the row each time, and index is going to be the index of that row as it goes. So the first time round, index is going to be 0 and row is going to be first row. Then the second time round, index is going to be 1 and the row is going to be the second row, and so on. So temp in F is the temperature column of the row, and then we can convert using the conversion, which is temp in F minus 32, because 0 degrees Celsius, that's the freezing point of water, is 32 degrees Fahrenheit, so we have to set the 0 points to be the same in the conversion. And then you go ahead and multiply by 5/9. Now, if you are doing this in Python 2, then you need to make sure that your 5 and your 9, or at least one of them, is a decimal, not an integer. Otherwise, you're going to end up doing integer division by accident. If you're using Python 3, then you can just write 5 divided by 9. That's not a problem. And then after that, we want to print out the temperature in Celsius. Okay, that's the plan. I'm going to give you a moment to just type this in and just see that it works. Then we'll come back. So let's pause. So if we run this, there we go. So hopefully you saw the same. Here's a conversion, and maybe these are temperatures which are more familiar to you down here. Nice. We can go ahead and add some extra things in to make this function more complicated if we want. Maybe we can decide that, I don't know, if the temperature is, if temp in C is greater than 27, maybe we can say, it's time for ice cream. I mean, I'm not sure how the mosquitoes would feel about this, but I think that would be a nice treat if the weather was that hot. So now we have things that are a little bit more complicated happening. We're printing out the temperature, and then we're doing something about it using an if statement. So let's run that. And indeed, every time it's more than 27, ice cream, ice cream, ice cream. Tragically, no ice cream, but ice cream again. There we go. All right. So now I've got a challenge for you. The challenge is to import the larger data sets. So here we go. I want you to import the data from A2 mosquito data. So this is the mosquito data which you downloaded, but there's a large data set, A2. And so feel free to open that up beforehand. If you import that into data 2, so at the beginning of this document here, we said data equals pd.readcsv A1 mosquito data. If you let data 2 equal A2 mosquito data here, then you're not going to overwrite data with the new data. It doesn't particularly matter if you do this by accident, but it's neater not to. So do this, then determine the mean temperature, loop over the temperature values. For each value, print out whether it's greater than the mean, less than the mean, or equal to the mean. Okay, it's never good. Between you and me, it's never going to be equal to the mean because of the fact that temperatures are integers. But I just want you to remind yourself of what if statements look like with some else's in, which is what this exercise is about. Plus, you'll have this imported for some exciting stuff in just a moment. So have a go now. So let's go ahead and do just this. So let's import the data. So data 2 is pd.readcsv, and it's going to be A2 mosquito data. .csv, there it is. Nice. We're going to determine the mean temperature, so we can say mean temperature equals data 2 temperature dot mean. All right, and enter allows us to do more than one thing. You see, shift and enter runs the whole cell, and then we're going to loop over temperature values. All right, so for index row in data 2.iterows, for each value, print out whether it's greater than the mean, less than the mean, or equal to the mean. All right, so let's temp equal row temperature, and then we can say if temp is greater than mean temperature, then print out hotter than mean. Elif, that's the else if command in Python, elif temp equals mean temperature. Then we can print out equal to the mean and else. And of course, you don't have to specify what else. We need the colon, because else is just otherwise. But you're going to print colder than the mean. Let's give that a run. Shift and enter. All right, so we have hotter. Oh, I've been inconsistent with the word the. Let's fix that. There we go. Hotter than the mean, colder than the mean, hotter, colder, colder, hotter, hotter, colder, colder. Do you get the same thing? Hopefully, yes. All right, so now I want to move on to the next section, which is plotting. And I think you're going to be impressed with how easy plotting is in with pandas. The first thing we're going to do is we're going to plot the number of mosquitoes, firstly against the year. All right, and then I'm going to ask you to do it against the rainfall. I think you'll be impressed. This is very cool. So first, let's take out the data that we want. So mosquitoes versus year. So let's select the columns we want. We want the year column, and we want the mosquitoes column. So let's go ahead and plot this. But before we plot this, if you want to see it in line in Jupyter Notebooks, sometimes you have to ask for it specifically. So we're just going to stick in a command for Jupyter Notebooks. It's a Jupyter Notebooks command, so it begins with a %. If you just ask matplotlib inline, then when we make the plots which we're about to do, then everything will stay in the screen. So let's go ahead and plot mosquitoes versus year. Mosquitoes versus year dot plot, and I'm going to let you go ahead and do this. See what it looks like. Decide whether you think it's good or not, and then come back to the video after the pause, and we will discuss it. All right, let's run this. Nice, and because we've used matplotlib inline, the picture shows up here. Is this a nice graph? Well, the year, mosquitoes, that goes up and down, but we haven't managed to plot mosquitoes against the year. In order to do that, we have to specify up here what we want on the x-axis. So inside .plot, you can specify x equals year. And so if you specify x equals year, then you get what you want. And this is a line graph, but you don't have to have a line graph. Of course, you could ask for something else. You could ask for a bar chart. And if you want a bar chart, you ask for kind equals bar. Kind equals line gave you what we just saw, by the way. There's a bar chart. Right, so that's an option as well. So I'm going to give you a moment now to use the data2 data sets, the larger data set. I want you to plot the number of mosquitoes against the rainfall. And you tell me whether that's good or not. Have a go, then we'll come back and discuss. Right, let's have a go at using this data set here. So we're going to plot the number of mosquitoes against the rainfall. So mosquitoes versus rainfall is we're going to pick out the columns we want. We want the mosquitoes data, and we want the rainfall data. Okay, and then we're going to say again mosquitoes versus rainfall dot plot, and on the x-axis I want the rainfall. And so I imagine you got something that looks a little bit like that, which is a bit of a scribble. Now, of course, the problem here is that this is I'm trying to do a line graph, and what I really want to do is a scatter graph. To do a scatter graph, we have to specify kind equals scatter. Now, some of you might have tried this. If you ask for kind equals scatter, it's going to give you an error because there's one other thing we have to specify with the scatter graph, not just the x-axis. But if we try it, I'll show you what the error message is. All right, so you see lots of arrows, but if you sort of head towards the bottom, it normally tells you what the problem is. Aha! Scatter requires an x and y. Oh, there's a typo in the arrow, that's fun. An x and y column. So if we go up here, sorry, it's here, isn't it? And specify x equals rainfall and y equals mosquitoes. There we are. That's more like it. Okay, so I'm going to give you an opportunity now to go ahead and fix that, and then let's come back directly afterwards. So we're going to pretty this graph a little bit up now. We're going to change the X and Y labels, and we're going to add a title. We can just do that by adding some stuff under the plot command. So we can say, let's have the X label let's be more specific. Let's say this is the rainfall in millimeters. I mean, the defaults are pretty good, right? This is already pretty decent, but we could be neater. And let's have on the Y label, let's have number of mosquitoes. Let's be more verbose. We can add a title, plot.title, something like mosquitoes like water, a quite clear correlation, and we'll talk about correlations in just a moment. So let's try that with a shift and enter. And here we go. Nice graph. Rainfall, number of mosquitoes, mosquitoes like water. Lovely. So your turn now. I want you to go ahead and to plot the number of mosquitoes against the temperature. And then we'll come back and I'll talk about one last thing. Nice. So if we go ahead and plot mosquitoes against temperature, then we could do, in fact, let's take mosquitoes versus temperature equals, let's use the data2 set. Let's pick out the mosquitoes and the temperature columns. And then we're going to do mosquitoes versus temperature dot plot, and we're going to have it be a scatter graph. On the x-axis, let's have temperature, and on the y-axis, let's have mosquitoes, like that. Let's give that a go. Not much of a correlation at all, I think. All right, we might talk about that in a little bit. So let's say you want to go ahead and save this now. Then in the same cell, you can just ask plot.savefig beautiful graph dot save PDF. So this is a better solution to saving it than right-clicking and going save image as, which is something that you can do, but then you only get the option of saving it as whatever format this is, probably some sort of PNG. This allows you to save it in whatever format you like. So for example, you can save it as a PDF. So if you run this, I can show you what that has done. So here's beautifulgraph.pdf. It's appeared in the same folder, and we can open up the PDF file, and you can see it has created a PDF file which is nicely cropped to sort of the area we might want, and you can zoom in as much as you like. You've got a beautiful vector graphic which is perfect for use in your LaTeX documents, for example. But if you want some other type of format, PNG, it's all there as well. You just have to ask for it. So that's nice. So for now, that's all I want to talk about with plotting. We'll do some more plotting later. I wanted to show you some of the other things that you can do in with Pandas. So here's the first thing. Let's talk about grouping. So grouping is when you have a bunch of data that you want to group by some column. So in the context of the exam results file, which we're going to be using in the second session, all of the students belong to a tutor group. Maybe there are 5 or 6 students in a tutor group. And the question is, which tutor group on average got the highest mark? So you would have to group the data by the tutor group and then work out, for example, the mean mark for that tutor group. Here we're going to try and group the data by temperature. Now this is a bit silly. Really, you only should be grouping data by discrete things. If you've got continuous data, then it's best to bin them, which we're going to be doing shortly. But just for the sake of an example, I'm going to show you what it means to group it by, in this case, temperature, which is silly because temperature is a continuous scale. But just to show you how it works, that's what we're going to do. All right, so let's go ahead and take data. We're going to, as I group the number of mosquitoes per temperature. So the idea is we're going to print out and then plot the mean number of mosquitoes for each temperature. That's the idea. So let's pick out that data. So mosquito data only. That's going to be, we're going to take the temperature data, and we're going to take the mosquito count data. That's mosquitoes there. All right. And then we're going to group this. So we're going to do mosquito data only, and then we're going to group by temperature. And once we've grouped by temperature, we're going to look at the mean. All right, I'm going to show you what this looks like, and then I'm going to point back at the original data. So what we've done is that we've grouped by temperature. This is on the small data set. We've grouped by temperature, and then we've put the mean. So let's have a look at what mosquito data only by itself looks like. So you can see that certain temperatures are repeated. 85 is here twice, 74 is here 3 times. So we're going to say group by temperature, which again is bad for continuous data, but just for this example. So now we have the mean number of mosquitoes for all the temperatures where it's 74 is 209. Do you see? The mean number of mosquitoes where the temperatures are 75 is 237. And so on. Now you have to tell Pandas what you want to do. You can't simply just do dot group by temperature, because if you do that, it doesn't know what to do. It's groups it and then what? So you just get this this sort of message back in angle brackets telling you that yeah, it's grouped it by temperature, but now it doesn't know what to do. You have to specify what you want to do once it's grouped. But now if you want to go ahead and plot this, it's really easy. You can just go ahead and plot, as simple as that. And look, here's the temperature, here's the mosquitoes, it's labelled for us already. Okay, not a particularly interesting graph, but let's see whether maybe the larger data file is able to give us any insight. I'm going to ask you now to do the same, but with the larger data file. So let's have a go, and then let's come back. So I asked you to do the same with the larger data file, and that really should not be too tricky. All you had to do was to go up here and change data to data 2, and then if we do the plot, okay, so still somewhat inconsequential. Okay, but the better thing to do with continuous data is not to try and group it, because it's sort of meaningless. Better instead to bin it. So this is section 6, and binning, here using a bin in the American sense of the word as a container rather than as something you throw rubbish into. Binning is this idea of you take your data and you put it into intervals or bins, right? So we're going to look at the years, and we're going to sort them into years that were dry, years that were normal, and years that were wet. In order to do that, we have to set up intervals on the rainfall for which we're going to consider dry, normal, or wet years. So again, you're going to be able to copy and paste this from the GitHub if you want. I'm going to type it in so that I can talk about it as we go. So we're going to have three bins, a dry, a normal, and a wet. But we have to think about the way that we type that in. So the first bin, we're going to have anything between 0 and 200 millimeters is going to be a dry year, and anything between 200 and 250 is going to be a normal year. Anything between 250 and 300 is going to be a wet year. Notice the way that we've done this. So we've set it up as a list. So there's three bins, but four endpoints, right? So it's fences and fence posts. So the first bin is 0 to 200. The next bin is 200 to 250. the final bin is 250 to 300. And we're going to give these labels. We're going to call it a dry year, a normal year, and a wet year. And then the command that we need in order to sort the data into bins is pd.cut. So pd again, pandas are pd.cut. And we're going to cut the rainfall data into the bins. And we're going to specify the names of these bins using labels. So I've written labels equals labels because labels is an optional argument, and the labels that we're going to give it are this variable labels here, which I've previously defined. So that's that. If I just do this, let's have a look what that gives us. So that shows us the 0 down to 9, so it gives us the 10 different years, and it tells us whether they were dry or wet or normal. What if we want to, I don't know, let's do a pie chart of how many wet years there are, how many dry years there are, and so on. That's fine. We can just do dot value counts to add up how many of each. So now we've got 4 dry years, 3 wet years. And if we want to plot it, just dot plot. And we want a pie chart, right? So kind equals pi. I'm going to let you do this. So let's pause. I'll let you do this. Hopefully you get a nice pie chart, and maybe you'll be impressed. Then I'll show you something else you can do. So your pie chart hopefully looks a bit like this. There you go. Okay, maybe it's not perfectly circular, but pretty good, right? Dry, wet, normal, nice. If you wanted, you could do it with the larger data set as well. In the larger data set, we have far larger number of dry years. Interesting. I'm now going to show you how to go ahead and add some columns. It's really easy, really straightforward. Let me show you how you can do it. We're going to add a column which is going to be the temperature in Celsius. So remember, I'm going to do it on the small data set. So this is what the data look like, remember? So I'm going to say, all right, data, and then I'm just going to invent the title, temperature Celsius. It's going to equal to data temperature, that's already there, minus 32, so here's the conversion we've already done, times by 5 and divided by 9. Again, remembering if you're using Python 2, then you have to use decimals here. If Python 3, you don't have to worry. Let's see what it's done. Let's have a look at our data. Okay, so you see it's popped it along down there. It's important to remember, this is something that we haven't really talked about at this point, but if you're adding extra columns, you have to make sure that you're adding columns to the entire of your data set. If you've picked out some rows from your data set, so maybe you've picked out the years or the rows corresponding to years where there are, where it's a dry year, for example, or the rainfall is less than a certain amount. You can't go and add a column to just those rows. You have to add a column to the entire data set. Otherwise, it's gonna throw a wobbly. You might come across this problem in the final project, but we'll see. The solution is to make sure that you add the row to everything in your data set. I'm going to give you a moment now to go ahead and do this, and then we're going to go and sort some data. Good, let's sort some data. This is section 8. The syntax is quite straightforward. Let's go ahead and play with data. Let's say we want to sort it on temperature. So we do data.sort values temperature. There you go, look, it's sorted on temperature. No problem at all. What if we want to sort it on 2 things, temperature and then rainfall? So every time we have the same temperature, I want to then sort secondarily on rainfall. So this time we're putting in the columns as a list. So once again, we need square brackets for the list. So temperature and then rainfall, like that. Here it is. So now it sorts by temperature, yep, and by rainfall, yeah, nice. If we want to go and sort descending instead of ascending, it's quite straightforward. You can just say ascending equals, and then you just say true or false for every item in the list. So let's say we want ascending is false, so that's descending for temperature, but we want it ascending for rainfall. So false and true, remember, in Python have capital letters. So let's give that a shot. Here it is. So the temperature is now descending, but every time the temperature is the same, the rainfall is now ascending. If you are just trying to sort by one thing, so sort by temperature, you don't need to have the square brackets, and you don't need the square brackets by ascending either. So sorting by temperature, ascending equals false, also works like that. Okay, I'm going to give you a moment to play with that, and then we'll come back and we'll wrap up this half. Okay, that wraps up part one of the course. In the second part of the course, we're going to continue. We're going to move on to looking at histograms, and we're going to look at regression. These are going to be nice and short, but you're going to be really impressed with the plotting capabilities of Pandas. It'll be very easy. And then the majority of the second half of the course is going to be involved with this large project. So in this project, as I mentioned at the top of the video, you're going to have a large data file full of exam results, and I'm going to ask you some questions. So that's all coming up in the second part of the course, and I hope you will join me for that.